Hi, in this lecture we would be looking at what we call as k-means clustering. So clustering is an unsupervised machine learning technique in which the goal of clustering is to group data. So k-means clustering is a popular method of grouping data into subsets. So you can group some data into sets of 3 or sets of 4 based on the similarity between the data. And how do you know the similarity between the data is basically by the similarity of the variables. So there is no different predictor and target variables here. Everything you can consider as a predictor variable. And we are looking at similarity between the values of the predictor variables to determine how these groups should be formed. So when you do k-means clustering, suppose you have n observations or rows in your data set and m variables or m columns in your data set. You then group them into k clusters. How do you group them into k clusters is that you group in such a way that every observation or every row is finally put into one and only cluster. So if you have rows and every row, let's say, represents a customer, and then you do k-means clustering, you go ahead and create k clusters, and k can be like 5 or 6 or whatever value, and you end up creating that many number of clusters, and every row or every customer is assigned to one and only one cluster, and that is called k-means clustering. How it works? So when you do k-means clustering, you create an m-dimensional space. So m is the number of variables or columns you have. You create an m-dimensional space and plot each of the rows in that space based on the values of the variable. So you plot every point in that space. And then you do clustering by doing what is called as distance measures between the points. So in that n-dimensional space, you measure the distance between each of the points and then use this distance to group the data. In the next slide, you are going to be seeing how exactly k-means clustering is done with an example. Multiple types of distance measures are available and know how to calculate the distance between point A and point B. And some examples are the Euclidean distance. Euclidean distance is finding the distance like as the crow flies, whereas Manhattan distance is a measure by which it is like a step-by-step kind of a distance. And there are a number of other distance measures also available, but the most popularly used measure is the Euclidean distance, which is like drawing a straight line between 2 points and using that to measure the distance between the points. So how does clustering work? So let us go through them stage by stage. The first stage here is on you look at the first plot. Now let's say consider the data set we are talking about. It only has 2 columns. So it is a 2-dimensional space, easy for you to visualize. That is why we are just considering a 2-dimensional space. So there are only 2 variables. And in this particular thing, I have an x-axis and a y-axis. And I just plot the points here. Suppose this may be like just age and weight, and maybe I'm plotting every patient that I have based on their age and weight in each of these dots. So all the green dots here represent one patient, and this is how they are plotted. Now I want to group this data into 2 clusters. So I can choose any number of clusters I want for it, but in this particular example, I'm only going to be choosing 2 clusters. So I'm just going to be choosing 2 clusters here, and then I'm going to start plotting. So how do I start the clustering? The first stage I do is I just choose 2 points at random. I call them centroids, but the first time I choose the centroids, I just choose them at random. So I just put 2 points anywhere in this particular chart. I'm just choosing, these 2 points here, but I can choose anywhere I want, and the algorithms typically choose what that random point is. Once I choose a point, the next thing I do is I measure the distance of every point to every centroid. Suppose I take this particular point, I measure the distance between this point and this centroid, and then again this point and this centroid. For every point, I'm going to be repeating this process of finding the distance between each point and each centroid. Then what do? I assign each point to the nearest centroid. I assign each point to the nearest centroid. So at the end of this assignment, every point is assigned a set of dots. So this particular blue dots are assigned to this centroid, and then the red dots are assigned to this centroid. Now this becomes your clusters for round 1 of clustering. So clustering happens in many rounds. The first round of clustering, these are your clusters. So you have the red dots forming the red cluster and the blue dots forming the blue cluster. So this is round 1. Now what do you do in round 2? Once you have the clusters formed, now find the center of each of the clusters, or the centroid of each of the clusters. How do I find centroids? Is I find a point within the cluster in such a way that the distance of each of the points within the cluster to the centroid is, the center point is minimum. The centroid is found in such a way that the distance between each point in the cluster to the center point is the minimum. So in terms, you're trying to find the true center of that particular group of points. So when I find the true center of that particular set of points, I end up here, the new centroid. So the centroids have actually moved from their original location to the new location. Now you see that these are the centroids. Now what happens? Now I go and repeat the process. I repeat the process of finding the distance between each point to each of the centroids. So I repeat the process of finding each point to each of the centroids and then assigning each point to the nearest centroid. Now when I do this once again, what is going to happen is the sum of the points will move between clusters. For example, this blue dot here, earlier it belonged to the blue cluster, now it will move to the red cluster. Similarly, some points that are here in the red cluster have become now blue cluster. As the centroid moves, the distance between the points and the centroids change. As a result, some points move between one cluster to another. Now I have a new set of new cluster, and for this new cluster, what do? I again go and find new centroids, and again trying to find the distance measure, and again trying to reassign points. So this particular thing of finding distance between the points and the centroids, finding a new cluster, and then finding the centroid out of a cluster keeps repeating again and again. And this process goes on for n iterations. And when does these iterations stop? When these points no longer move between clusters. It stops when the centroids become stable, they don't move anymore, and then the points don't move between clusters. It is that place that the clustering process has come to a standstill, and that is where you get the real clusters. In this case, the points are really spread out to each other. So within a few iterations, you have got into the final outcome of finding the centroids and the points. Sometimes, if the points are all intermingled with each other, it may take a lot more iterations before you end up coming up with the real clusters. Not all clustering algorithms will typically go until the end. They would typically stop after some X amount of iterations. They have some internal measures through which they figure out when the clustering process is kind of optimal or complete, and then they stop at that point. But this is the basic mechanism in which k-means clustering works. Finding the centroid, assigning points to the centroid, and then reassigning them, and this process keeps going on. So this is your clustering process, how k-means clustering works. So advantages of k-means clustering compared to, there are other types of clustering like hierarchical clustering. There are other variants of k-means clustering also available, but all of them typically work with the same kind of concepts. What are the advantages of k-means clustering is that it is fast, it is efficient for a large number of variables. Okay, it can be even if there are like 20 or 30 variables in there, k-means clustering can work fine. It is explainable. It is easy to explain why these points have been assigned to these clusters. It is usually pretty easily explainable. Shortcomings is that you need to know k upfront. So if you have a group of data, how do you predetermine the number or value of k? How do you know that this particular group data set I have actually have 3 logical groupings or 5 logical groupings or 4 logical groupings? I don't know that upfront. So you need to know k beforehand for you to do k-means clustering. One way of overcoming this is actually trying to do clustering for all kinds of values, like take the same set of data and do 2, 3, 4, 5, 6 kind of clusters. And on that, you're trying to find something called as, the distance, what is called the separation between the clusters, which is measured by the sum of squares kind of a logic. you would see that when we do the example, the use case for k-means clustering, you do that repeatedly, and then you draw what is called as a curve for this sum of squares, and wherever there is a knee in the curve is where you determine that particular clustering is complete. We will see that example when we look at the use case, how to find the knee in the cluster. The initial centroid position has influence on the actual clusters formed. Wherever you put those dots up front, sometimes they do influence the actual size and shape of the clusters. Sometimes what happens is, if the points the initial centroids start in a different position, the points might actually end up in different clusters. So the initial centroid does have an influence on the clusters being formed. So that is one shortcoming. There are other clustering variants which take care of this kind of a shortcoming too, but k-means clustering by default relies a lot on this initial centroid. If the points are too close to each other, then the clusters formed are influenced by the initial centroid that is used. It is used in preliminary data grouping of data. A lot of times clustering can be used like a preliminary grouping of data. I first group the data into 3 or 4 clusters, and then start doing machine learning or individual clusters and see how they behave. Sometimes it is used like a preliminary clustering technique. It is used for general grouping of data, like any kind of data, like documents grouping, finding groups of documents and stuff like that, groups of websites, search text, things like that. It is also used for geographical clustering, where you have the longitude and latitude as the variables and then use them to find logical groupings of data, such that you find some true centers and true groups of data in a geographical setup. So that is another use of k-means clustering.